Okay, so let's look at this question. There is a hinge here, point D, and there is a hinge at point A, and look at this, 2 meter, 2 meter, 1 meter, and this is a cable, DC, CB, and BA, and look at this distance, DB and DC, and the load 2.25, and the load 3 kilonewton. Let's look at this question. Two loads are suspended as shown from the cable ABCD. So this is the cable A, B, C, D. It's a cable. And there's two loads, 3 kilonewton and 2.25. Knowing that DC is 0.75 meters, so the distance C, this one is 0.75. From here to here is 0.75. This is like a horizontal line, and the distance between this horizontal line and point C is 0.75 meter. Determine, first of all, he wants the distance dB. He wants this distance, dB. And he also wants the components of the reaction at A. He wants, remember, there is a reaction at D and the reaction at A. He needs the component at reaction at A, AX and AY. And at the end, he wants the maximum tension of the cable. Of course, this cable has a tension inside. What is the maximum tension of the cable? Beyond that, this cable will break. Let's look at this question. So we'll try to rearrange the equation. We need to find out the distance dB, knowing that DC is 0.75. We need to find the component of the reaction at A. We need to find the maximum tension in the cable. So we will draw it like this. There is two hinges, hinge D and hinge A. Okay. Let's look, first of all, let's strip everything from it like this. Let's just look at this one. Here there is a hinge. So there is two reactions, AX and AY. And here there is a hinge. There is DX and DY. You can see it, a cable. And there is reaction D and reaction at the A. So you could do it like this. AX. If you do it like this in the negative x-axis, if the value is negative, which means that it's the opposite direction. So let's assume it AX like this and AY like this. And this is the cable. This is point A, of course. This is B, 3 kilonewton, and C, 2.25, and D, and then DY and DX. So this is the way we do it. This is the cable free body diagram. Now, let's do something. The best here, since we have four unknowns, let's take moment at point A. Moment at point A here. So summation of moment at point A, you can see that this force will do a clockwise, which is what? Negative. So 3 kilonewton times the distance perpendicular. This is this perpendicular distance from point A. So this is point A. Okay, so this perpendicular distance, what was the value of this distance? You can see it here. It is 2 meters perpendicular from this point to this point. So we will make it minus because it's clockwise. So it is minus, what is minus 3? Minus 3 times 2. Minus, look. Let's look at the other one. Again, it's a point A. This force will do the same thing. Will push the whole cable clockwise around my finger here. Okay, so this 2.25 will go clockwise. So 2.25 times the perpendicular distance, which is look at this. Point C, perpendicular 2 plus 2. So it's 4 meters. Point C, it's 4 meters. So it is minus 2.25 times 4. So it's minus 2.25 times 4. Look at this, minus. And now, since we are doing summation moment at point A, you can see that this force is in the same line of action. So we don't take dx. It is cancelled. dy, look at this. Moment at point A, dy will take it counterclockwise. It's a plus, but it is from D to point A. From D to point A, it is 1, 2, 2. It's 5. So it is plus dy times 5. So look at this here. Plus dy times 5. This is summation moment at A equal to 0. You get this, you could find dy. dy is equal to 3 kilonewton. So from this moment at A, we find dy. Now, if we know dy, we could find ay easy, because if we take summation of forces at the y-axis, dy, which is we know here, it's 3 kilonewton. dy minus 2.25 minus 3 plus ay, you could find ay easy. Now, so we'll do that. Summation of force at y equal to 0, ay minus 3 minus 2.25 plus 3 kilonewton equal to 0. ay is equal 2.25 kilonewton. Now we're done from this. Now let's take point D as the free body diagram of point D. Let's look at point D. At point D, there is dy and there is dx and there is a cable. We'll take only point D, free body diagram. Point D, remember, it's going down like that. So we'll do it like this, which is the tension CD. Tension CD, it's the same tension of the whole cable, because remember, this cable, CD, is all connected. So the cable of the whole, it's, once you find this cable tension, it's the same. So cable, I'm going to assume a tension CD. So I'm going to do it like this. This is point, this is point D. This is dx, we don't know. This is 3 kilonewton known. And there is this tension, and this tension is, look at the angles, 3 and 4. How did he find the angle 3 and 4? Let's go and look at it like this. Remember, if you want to find this one, you need to know what is this x-axis. Let's go and see the actual here. It is 1, okay? And what is DC? DC, he gave it to you. It's 0.75. So this is 1. .75. So 1 and 0.75 is like 3 and 4, but we could just leave it at 1 and 0.75. It's the same thing. It doesn't change anything if you make it like this, and if you put it as 1 and 0.75, okay? It's the same thing as the put 3 and 4. And we will put it as 1 and 75 because that was given. But here he just like he knows 1 and 0.75 is equivalent to 3 and 4. First of all, remember here that we have this one could go y and x, and this could go only x. So let's find summation of forces at the x. Now I'm gonna do it as this one. Okay, so summation of force at the x equal to 0 minus ax. Here. Ax is equal to dx. Okay, so we'll do that. Summation of forces at the y. Summation of force at the y is 3 kilonewton up. And then, so if you do summation of forces at the y, let's do it here. Summation of forces at the y equal to 0. Remember, it's here. It's 3 in the plus. It's 3 plus, and then you have this one going negative. So this one is either in the negative x or in the negative y. So minus TCD. And I'm going to do it 1 and 0.75. So 0.75 in the y. So we have to know what is the middle one here. So if you make it 1 Okay, you know, 0.75, it means what? It means 3 and over 4. Okay, because 3 4 is 0.75. And since this is 1, you take the 4 to the 1 and you make the 3 in the x, in the y. So this is 3. And because 3 and 4, we know this one is 5. So I'll do here TCD, it's negative. It was 4 over 5. Again, you could still use this one, 1 and 0.75, but we need to find out 1 square plus 0.75 square all under square root to find out this. And you could just redo it in your calculator and find out. It's going to give you the same answers. So, plus 3 minus this equal 0. You could find TCD. So, 3 minus 3 over 5. Oh, this is, sorry, 4 is here. You take 4 is here. Here is 3. So it's 3 over 5. So minus TCD, 3 over 5, 0.3 kilonewton is equal to 0. You could find TCD is equal to 5 kilonewton. So we found the tension. TCD, and its tension is plus, so it's tension. So TCD is equal to 5 kilonewton. Now, let's find out summation of forces at the x equal to 0. Remember that, this one. We have dx, and we have this one, minus TCD 4 over 5. So we have we have summation of forces at x equal to 0. We have dx, this is dx, not dy. So we have dx minus TCD 4 over 5. Okay, times, of course, now we found TCD 5. So we could find dx. dx is equal to 4 kilonewton. And it's our assumption is going to the positive. So now we found dx, and now we found ax. Okay? Since we found both, we found TCD, and we found dx. Now let's find ax. Ax is by finding summation of forces of x equal to 0. Remember, let's go to the ax here. The total cable. Remember that we have ax to the negative and we have dx to the positive. We just found dx, so summation of force at x equal to 0. We know that minus ax plus dx equal to 0, ax equal to dx. dx we just found 4, so ax is also 4, and it's the opposite. Remember, ax, it was in the opposite. So we found all these values. Okay, now we should find out the distance, because he wants to find out the distance B. The distance, that's what he wants to find out. So let's go to point A. So we go to point A. In point A, we have AY, we have AX, and we have this tension, TAB, which is the same tension CD. It's the same cable. And remember, now we should find out this one. What was this one? What was this value? It was 2, and this one is unknown. So this is 2, and this is dB. So it's like this. 2.25 we know. 4 kilonewton we know. This is point A. 2 meter we know. dB we don't know. Tension AB, which is the same thing. Now we could redo the triangles. So this is distance B. You could do it like this from point A. Distance B divided by 2 meters. Okay? distance B divided by 2 meter is equal to 2.25 divided by 4. So you can see that this is an extension to this, and this is almost parallel to this. So we could see the triangles DB divided by 2 is equivalent to 2.25 divided by 4. So we could find DB now. DB is equal to, DB is like that, is equal to 1.25 because if rearranging this equation. AX we found before 4 kilonewton. AY we found before 2.25, and look at the directions. This is going to the left, this is going up, and Tmax we found it 5 kilonewton. Okay? Thank you very much.